How to build a Blackgates Sweet Pea 5-inch gauge locomotive, part 22. A quick weld repair to the pony truck was unsuccessful. Instead, I made a new part entirely from 1/8 mild steel plate. This was how I received the locomotive. As you can see, something's gone wrong. I really can't live with this, it looks horrible. That's why I thought, I know, I'll do a quick repair with my MIG welder. Just pop a small amount of weld in the top. That was a bit of wishful thinking. Welding is not my strong point, as you will see in a moment. Initially, I set the welder to quite a high amperage to make sure I got full penetration on the joint, but it was a little bit over the top, so I dropped the power down and steadily built up a lump on the end. And in no time at all, not only was the end bit repaired, the entire hole was filled. I don't do much of this sort of thing. How did you guess? Not only was the end part of the piece of metal filled, the entire hole was filled, but I thought, well, this will be okay. I'll take it from there and grind away the excess weld to end up with a nice flat metal plate. I fitted a new sanding belt to my 4-inch belt sander and tore into the piece of metal. It's actually wet, because while I was grinding down the weld, the part got very hot, too hot to touch, and I don't wear gloves in the workshop, as I've mentioned many times. So I had a pot of water right by the belt sander, and I kept dipping it in that. The next part of the job is finding out the diameter of the pin that goes through the hole that used to be in the end of this piece of metal. Over now to the drilling machine, and as always I start off with a centre drill. That way I can make sure that the hole is in the right place, and it seems to be drilling okay, but then when I tried to run a 7/32 of an inch drill bit through, it wasn't having any of it. That is because it was blunt. A 7/32 drill bit in my workshop gets a lot of use because it's tapping size for 1/4 of an inch. I drilled through with the 7/32 of an inch drill bit just to make sure the hole was in the right place. Then I went through with a 1/4 of an inch drill, which was actually a bit small, so I opened it up with a reamer and this happened. To be honest, I did notice a crack whilst I was drilling it, but I carried on for the purposes of the video. I could start again and re-weld the end, but I'm not going to do it. I'm going to make a new part. This part is critical. If it falls off while the locomotive is running, then there's going to be a derailment. And we don't want that. I found a piece of steel plate 1/8 of an inch thick, which was just the right size to cut a new part out of. All I did was place the old part on the steel plate and mark it out with a felt tip pen. Now I have a line to cut to. All I need to do now is cut out this part from the 1/8 of an inch piece of steel plate. I have an old bandsaw in the workshop that I've had for many years, and you can use it horizontally or vertically. For this job I'm going to use the bandsaw in the vertical mode and feed the piece of steel through the bandsaw blade by hand, but first a serious health and safety warning. Using a bandsaw can be dangerous if used incorrectly. As the blade approaches the end of the cut, always apply less pressure to the part so that the bandsaw blade breaks through very gently. By reducing the pressure that you put on the blade at the end of the cut, it will stop you from sawing your arm off. This is a serious health and safety warning. I once let a friend of mine use my small bandsaw and he managed to bandsaw his thumb, and I remember thinking, well, that was a stupid thing to do. And now my trusty bandsaw is covered in blood. Just to recap, lay off the pressure when you get to the end of the cut. Watch this. I'd already cut down from the other side to get the edges square, and by the time the bandsaw blade touches this junction, my left arm does not also go through the blade. One side done, now to do the other side. Same principle. I'm actually putting quite a lot of pressure on the piece of steel to force the bandsaw blade through it, because this bandsaw blade is not as sharp as it once was, and by the noise it's making, it's damaged. I don't think it's long for this world. But as usual, it did the job, and eventually I end up with the shape that I require. Here I'm using my 4-inch belt sander to clean up the part. There's a problem with this though, it's getting very hot indeed, and I don't wear gloves in the workshop. I've explained many times why. I like to know where my fingers are at all times. I rounded the end as shown using my 1-inch belt sander, then I went back to the 4-inch belt sander and continued the job, and I ended up getting a very good finish on all sides of the part. The last thing to do is to deburr the edges so it isn't sharp. Back into the workshop now. I'm using my latest acquisition, a battery-operated orbital sander, just to roughen up the surface in anticipation of a forthcoming paint job. This next clip is quite rare on my channel. I often show paint drying, but I don't think I've ever shown marking out fluid drying, and here it is, drying right before your eyes. It's actually surprising how quickly the solvent in this stuff evaporates, and in no time at all it's ready to use for the marking out job. I'm marking the positions of these holes and the other 3 main mounting holes onto the new part. As this part is going to fit other existing parts, it's really important to get these holes in the right place. Less so with the main hole for the pin, because I know where that's supposed to be. After drilling the holes, I'm removing the burrs using a twist drill. And to finish the job, it's back to the orbital sander. This is so incredibly useful. I bought the smaller battery just so it was light in weight, and this battery is lasting for ages. And it doesn't create a lot of dust because there's a box on the back that catches it all. As you can see, it makes a really good job of cleaning up the surfaces of pieces of flat metal. A quick flashback shows what I started with, the other piece of metal, which was a bit of a mess and totally unfit for purpose. Was it worth making a new part? Yes, it was. And although this area of the piece of steel is not visible when the locomotive's all bolted back together, that is not the point. Here's a new part looking like it's supposed to look. I will conclude this episode with the statement that my father used to drill into me from an early age: if a job's worth doing, it's worth doing well. And that's it for this one. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.